Okay, problem 81 and 82. So on 81, guys, what's tricky about this one is if we try to graph the system, you have to remember the exponential functions have this shape, and they're going to have an asymptote on the x-axis. And because of that, finding where these two, they're both exponential functions, right? They're both going to have a very similar extreme value over here where potentially they will intersect. But my point is this one is probably impossible to solve, like problem 80 using graphing. So we're going to have to brute force this one and try to solve this using algebra. So what are we going to do here is, well, what I decided to do was, let's just go ahead and get rid of the 4 power here by doing a log base 4 on each side. A log base 4. Now on the left side it works out really nice. A log base 4 on the 4 gets rid of the 4 base, and all I'm left with is just x. And it's going to equal, now over here what do we have? We have the log base 4 of 5 to the x plus 2. So now what are we going to do? Okay, is we're going to use one of our log rules or properties. We're going to bring that exponent down. Remember, we can bring an exponent down and make it a multiply in front. So x, in other words, would equal x plus 2 times the log of 5 base 4. And we can calculate what the log of 5 base 4 is on our calculator. Remember, we're going to use change of base. We're going to do the log of 5 divided by the log of 4. Okay, and that's actually going to come out to be a numerical value. So if you look right here, I took the log of 5, which is this. I divided by the log of 4. So I'm going to say 1.161. Rounding that 9 off and making that 0 or 1. So 1.161. Okay, so now what? Well, what we have here is x equal to 1.161 times x plus 2. And I can distribute this 1.161. And what I'm going to get is x equal to 1.161x plus 1.161 times 2. From there, sorry I kind of ran out of room here, guys. I'm going to clear part of the screen, so pause it if you want to copy any of this down. Okay, hopefully I gave myself enough room here. Oops. So what we're going to have, of course, is I'm going to get my x's together. I'm going to minus 1.161x from each side. I know that's hard to see, but basically, if I have 1x and I minus 1.161x, that does equal to 2 times 1.161. Now I'm going to do a lot of calculations with my calculator here. That's a 6 right there. And so I know that 2 times 1.161 is 2.322. So 2.322 equals, and here I'm just going to take 1 minus 1.161 to combine the x's. And 1 minus 1.161 is negative 0.161. So negative 0.161x equals this. So to find x, I'm just going to divide by negative 0.161. Now I hope you're able to follow that, guys. And so I end up with the answer, negative 14.42. And that's what we're going to go with. If x is negative 14.42, guys, we will ensure that 4 to the x equals 5 to the x plus 2. So maybe you need to watch this video more than once, especially with my small writing and work here. It may take a few tries for you to truly understand what I did. And again, study my calculator work here. Okay, guys? But that's our answer, negative 14.422. And we're just going to go with that. Okay, what about 82? Well, here's basically what this one is, and I think it's too open-ended. But the idea is, here we have Tyler, and let's say he's right here, and he's looking up, and this is what we call, in this case, theta is going to be what we call our angle of inclination, right? Because anything at incline is looking up. That's where they get the name angle of inclination. And he's looking up, it could be she, of course, whoever, at this big steel bar that's being raised up by some crane out of the picture here. But as you can see, we basically have a right triangle here. And we want to know, and we're also told right here, if you read, that Tyler's 250 feet away. So we know this distance is 250 feet. So long story short, if we want to know the height of that piece of bar or metal, what is the opposite of our angle? And this right here is the adjacent of our angle. We better know our SOHCAHTOA, some old hippie caught another hippie tripping over apples, because that's how we know that we're going to do tangent. So because this question is so open-ended, the only thing I'm going to leave you with is we should be able to say that we know that the tangent of theta, our angle of inclination being theta, has to be whatever the height is, opposite here, divided by 250. And that's the best we can do. Now, technically, though, that's not totally right, because we have to know how tall Tyler is here, right? So let's say Tyler's 5 feet tall. Well, that means actually, if we're just looking at a height level, no, what that means is we have an extra 5 feet we got to account for over here. So, let me think here real quick. But anyways, I'll just leave it at that. But we may have to add h with 5 to make it h plus 5. Yeah, that would actually be his actual height. Okay? So technically, that's what we're really looking at here. All right? But again, this problem was way too open-ended, so don't stress out too much about that one. But you better know how to do 81 here. And hopefully you understand using algebra and brute forcing it. To get rid of a power, you do a log. So to get rid of the 4, I did a log 4 on it. And then here we had a case where we better know how to do change of base again. So that's it for problem 81 and 82.